Okay, so skill 29 is the percent change shortcuts. So this is basically a skill that talks about the challenging things dealing with percents in general on the ACT. You might get a very easy percent problem, like, I don't know, they give you something and they ask for what percent of it is. But in general, you're not going to get that. You're going to get a variation of one of these three problems, and very likely you'll get two out of these three. So these are the three types of problems that are challenging and how to deal with them. So first of all, the percent change formula. So when a question asks what is the percent change, all right, this is how you have to do it. The percent change is the new value minus the old value divided by the old value times 100. All right, so let me give you an example. If the question asks you to calculate the percent increase from 75 to 97, you would have the difference between 97 and 75, okay, which is the new value, which is 97, minus the old value, divided by the old value, times 100. So that's a 29.33% increase. Another way that I like to remember this, if it's easier, is to say that this is, oh, that's not working, sorry. This is the difference divided by the original, and you take that. So by the difference, it means the difference between the two values divided by the original value, the starting value, and you multiply that by 100. So that's exactly the same thing as this, except just slightly different wording. So that's one type of percent question and that shortcut that you need to know. The second is how to quickly add or subtract a number by a certain percentage. How to quickly, in other words, increase or decrease a number by a certain percentage. So let's say you want to increase 42 by 63%. Okay, the shortest way to do that is to multiply 42 by 1.63. Okay, if you multiply 42 by 1, you're not increasing it or decreasing it. It's the same. That's why you need the 1 there. If you want to add more to it, it's 1.63. So the only part that you're adding is that 0.63, which is 63%. If you wanted to increase 42 by 132%, then 1.32 isn't going to be enough because the 1 by itself just keeps it the same. So that becomes 2.32. If you want to decrease it by 20%, okay, then you multiply it by 0.8 because what you're trying to do is take away 20%. So you're taking away 0.2, which is 20% from 1, so you're multiplying by 0.8, all right? This is a very important and useful strategy for percent increase or decrease problems. Until students get these right, I often see them getting these types of questions wrong until they know these shortcuts. All right, third and last, a type of problem that students often miss. Here's an example. Amari works at an electronics store where he gets a 20% discount off everything he buys. If he paid $50 for an item, what was the original price of the item? So you got to have a red flag whenever they ask about the original price. What students tend to want to do is take $50 and add 20% to it. So that would look something like this: multiply 50 times 1.2. But that's not right, because what's happening is the 20% is coming off of some other number, and that's what they're asking you for, okay? So you have to take the original item as X and then multiply it by 0.8, which means the same thing as decreasing it by 20%. So X times 0.8 is a 20% decrease of some item, and we know that that ends up equaling 50, okay? So then you do the algebra. 50 divided by 0.8 is 62.5, okay? If we would have added 20% to 50, then we would have gotten 60. So it's not the same thing, okay? So whenever you have an original item, set it up right, turn the original item into X, and then take the decrease or the increase or whatever it is and make it equal to the discounted rate or whatever it is. Okay, so to sum up, you got to memorize the percent change formula, the difference divided by the original times 100 is the percent change. You got to know this one-step shortcut to add or discount a certain percent from a number, okay? And then third, you got to set up work problems involving original amounts correctly, label the original amount as X, and then take it from there.